Today we are going to create a foldable for our notes over the slope of a line. The first thing I need you to do is to take your note sheet, and where this outline here on the pages, I need you to trim all the way around it. Doesn't have to be perfect. We're just trimming down the excess so it fits in our notebook. Okay, then after you trim down the extra paper that we don't need, we're going to fold this so that we can make some windows. We'll start on this side, and we're going to fold it just until the letters are clearly shown on the outside here. So just past the D here. I'm going to fold it and make a flap so it opens up like this. Then where I see these lines here, I'm going to trim it down. I'm going to make little windows. And these two windows are the only ones we need, so this paper on this side is excess. I don't need it. So where I folded it, I'm going to cut it off. So you have two little windows on the right-hand side. Then I'm going to do the same thing on the left. I'm going to fold it right past the letters. Then I'm going to cut my windows open. And I'm going to trim off the excess piece that I don't need. Just like that. And you've created the windows that you need for your notes. Now some of yours are going to touch here in the middle, some of them aren't. It's just how it gets copied. And inside the flaps is where we're going to put our notes. So we're going to start with here. The definition, it's not technically a definition, it's just a statement that describes slope for you. It says slope measures the steepness of a line. It is also called, and slope is also called, a rate of change. Which we illustrate with the fraction delta y over delta x. And delta is that triangle that just stands for the words change in y over change in x. And that's actually how we solve for slope. We're going to start here on the left with positive slope. A positive slope will rise from left to right. And it looks like this. And this is kind of like you're going uphill. For your slope to be positive, the actual value has to be something that is greater than 0. And we talked in the past about m represents slope. In this case, m will be bigger than 0. So that's all your positive numbers, like 1, 2, 3, 4, etc. And I'll give you an example. Y equals 2x plus 1. Our slope, remember this comes from that equation y equals mx plus b. Our slope is the m, it's the value in front of x. So in this case, m is a positive 2. Now if we represent 2 as a fraction, that's like saying 2 over 1. And the top part is the change in y, so that's how we go up or down. Since it's a positive 2, we go up 2. And on bottom, that's our left or right, that's our change in x. So in this case, it's a 1, so we go to the right 1. And that's how you'll graph the points. Now you start at your y-intercept, which is that b value, which is that number by itself, which is right here, b equals 1. So I'm going to come over here to the graph. I'm going to go to the point 1 on the y-axis. And then I'm going to count my slope. I'm going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and I'm going to put a point. Now you can also graph backwards, starting with the y-intercept and going backwards. All you do is you reverse your arrows here. Where these arrows say I go up 2 to the right 1, I'm now going to go down 2 and to the left 1. So starting at my y-intercept, down 1, 2 to the left 1, put a point. Down 1, 2 to the left 1, put another point. And you can do that as many times as you need. Usually I ask for a minimum of 3 to 5 points to graph a nice line. In this case we have 5. So we'll go ahead and connect the dots and make a line. And you can see that when we graph that slope, our line from left to right is going up. Then the next one we're going to do is our exact opposite, which is a negative slope. And for a negative slope, our slope will fall from left to right. Which means it looks like this. Whereas this one says we're going uphill, this one is more like we are going downhill. In this case, slope is a value that is less than 0. So that's all your negative numbers, negative 1, negative 2, negative 3, etc. An example of an equation with the negative slope, I'm going to give you an easy one, is y equals negative 2x plus 1. This time when I pull out slope, slope is a negative 2. The number in front of x is a negative 2. So if I show that as a fraction, that's negative 2 over 1. And the negative on top says instead of going up, I now go down 2. I'll still go to the right 1, but when I count, I'm going to start by going down. In this case, b is still that positive 1. So now I'm going to come to this graph over here. I'm going to start at my y-intercept of a positive 1, and this time I'm going to go down 2 to the right 1 and put a point. Down 2 to the right 1 and put a point. Down 2 to the right 1 and put a point, etc. To do the opposite, instead of going down and to the right, I could possibly go up and to the left. So I'm going to come back to that original y-intercept and I'm going to go up 2 to the left 1, because that's the exact opposite of my down 2 and to the right 1. Then once I have 5 points, I'm going to connect those dots. And you can clearly see that the slope is now going down from left to right. So that's a positive slope and a negative slope. The next one we're going to talk about is a zero slope. A zero slope is a constant number, and it creates a horizontal line. So your line looks like this. One of the best descriptors that I've had so far that I think will make the most sense for you is that this line is flat. It's a flat line that goes horizontal. Now it's called a zero slope because quite literally the slope value is 0. So for this, the value of m equals 0. It can't be anything else. To be a zero slope, it must equal 0. So an example of a line with zero slope would be y equals 4. This is actually the same thing as saying y equals 0x plus 4. Because 0 times any number is 0, we don't have to show this, and we can just say that that is y equals 4. So if I was to pull the slope out of this, this would be m equals 0. To show it as a fraction, that's like saying 0 over 1. So up and down, I don't go up and down any. 0 says I don't move up and down at all. So there's no up and down movement, but I can still go to the right 1 from that point. So I won't move up and down, but I will still go to the right. My y-intercept is still the number by itself that's not in front of x, and in this case that y-intercept would be 4. So I'm going to come over here to my graph. I'm going to go to 4 on the y-axis. 1, 2, 3, 4. I'm not going to move up and down any, but I'm going to go to the right and put a point, to the right one and put a point, to the right one, to the right one, until I have 5 points to graph my line. And when you graph your line, it should be parallel to the x-axis. Now, your line could be the x-axis. If it is not the x-axis, it'll be parallel to the x-axis, and it'll be a line that looks like this. It's exactly parallel. Let me highlight that for you. It's hard to see. This line is exactly parallel to the x-axis. And that is a zero slope function. Now, the last one we're going to talk about is that undefined slope. This is a vertical line. And one of my kids in my last class said that this we can call consistent. We didn't want to call it a constant so that we didn't confuse it with the horizontal slope, but it is still consistent. It's still a single value. In this case, your line will look like this, up and down. It's a vertical line. And the best descriptor we've seen so far of that is just simply to write up and down. In this case, your slope is a value that we cannot define. We do not have a definition for it. So we say m equals undefined. You can abbreviate that to m equals UND. That means the same thing, undefined. So an example of a slope that is undefined would be like saying x equals 4. In this case, it's not even in the form y equals mx plus b. This is an equation x equals 4. So our slope is like saying 1 over 0. And if you were to type that in the calculator, it would tell you error because you cannot define that. You can't divide 1 by 0 because you can't put 0 into any number. So in this case, 1 over 0 is an undefined slope, but this will give you an idea of how you would graph it. So in this case, since I have a positive 1 on top, I would go up 1, and I go left and right, none. I don't move to the left or right. It's simply just going to go up. I do not have a y-intercept because I have x equals 4. That's not a y-intercept. That is an x-intercept. So in this case, where it says x equals 4, I'm going to go to x equals 4. I'm going to go on my x-axis to the value of 4, and that's going to be my first point. And then my slope tells me I go up 1 and left and right none. So I'll put a point directly above it. And then up 1, up 1, up 1. And you can see here that instead of creating a horizontal line, it's now creating a vertical line. Just like this. And again, that's hard to see because it's right in line with that dark graph. So let's go ahead and highlight that. So you have a positive slope that rises from left to right. You have a negative slope that falls from left to right. You have a zero slope that is completely flat line that is horizontal, and you have an undefined slope that is a completely vertical line. Okay? Now you're going to take this foldable. You're going to close your windows. You're going to find the next page in your notebook, which in this case for me is page 15. We're going to title it Slope is rate of change. Which is the change in y over the change in x.